Well, welcome back to the Collision Hub World's Fair. Hey, we our final show of the day.
Yes.
Today went a lot quicker than yesterday, but I guess it's a little bit earlier than it was yesterday, right?
We started about the same time, but we had it spread out a little bit differently, and we don't have the late show today.
Yeah, we don't.
A little bit earlier.
Tomorrow night we will, though, again.
Yes.
So, hey, we're with the Celette team, and we've got our Nissan Sentra
They're
here.
behind me, right?
They're still here, yeah.
They're still
here.
there.
They've been busting their tails for a while now, so they look. We're giving them a break right now. Let them chill out a little bit.
I was fresh air inspector. I'm a little.
Yeah.
Got a little perspiration going on.
We're the support team while they're getting set up here. We did a great job of supporting them by telling them to hurry up.
Yes.
And let's get
mush.
But hey, guys, thanks for being with us this afternoon, and we're looking forward to talking about some structure repair. And so we've got this Nissan that we hear, and we talked a little bit about it.
This is a Mercedes, no?
Well, it's
somebody lied to me.
Well, it's silver. They got some
it's silver.
It's silver, so that's good. So. But anyways, we've got this vehicle. We've done some measurements on it. We're going to talk a little bit about that, and we're going to talk a little bit about setting this up on the fixture. Talk a little bit about some advanced structural repairs and some of the technology in this vehicle. And we talked a little. Larry and I spent a little bit of time talking about some of the clap zones and the sacrificial rails that they've got on today's vehicles, and how that kind of played into this particular vehicle as well. So. Why don't we start with the measurements on this vehicle? So we had this up on the twin post lift earlier.
Right.
And we got some measurements off of it, and I think, Greg, you're going to kind of walk us through some of that, and kind of we'll have a conversation. We'll kind of like what that's telling us, what that's going to mean for our repair process. Obviously, we've got some extensive damage that we know is going to require replacement, but we want to talk about how far back the damage went. I got some questions for Larry that I prompted him with a little bit earlier, so I unfortunately gave him a little prep. I should just not do that next time. But
well, the basic concept here, guys, is I want everyone to understand, and who's watching out there. Greg, tactically, let's pretend he's not working for Celette today. This is a body shop. Jason's the manager. I'm the estimator.
Well, I'm going to go back up to the front office.
I'm going to go to the front office. In the air conditioning.
It's time for a coffee break, isn't it?
Yeah, right, exactly. Union break. And Greg was actually our blueprint tech. So Jason and I did an earlier walk through the yard, and we try to classify the jobs as fast, quick, or extended. In this case, this is actually an extended repair. We really wanted to measure this. And
well, before you get into that, though, when you break those down for us, your fast, regular.
Well, a fast repair would be, let's say we had a bumper cover that had some scrapes on it. Maybe a headlight has a scrape and a fender has a repair to it.
Okay.
We bring it in and measure it, and we find out that the structure's okay, the suspension's okay, upper structure's good. Okay, this is a fast repair. It goes back outside, parts are ordered, disassembled lightly.
And we won't know that till we measure it.
Till we measure it, got to measure it. A fast repair would be, let's say it needs the same parts, but let's say this is a bolt-in rad support, and let's say the rad support that's bolted in is damaged, but it also pulled the rail in like 7-8 millimeters at the top. Can't hit it with a sledgehammer, can't hit it with a rubber mallet or a piece of wood. I actually got to pull it. So that would be it's going to take me longer to put the car on the bench than it would actually be to pull the car and fix it. So that'll be a fast repair. I know I can schedule that in and out. And then an extended repair is obviously something that, I mean, this car's pretty bad. You can see the rail's pushed over a lot, and we have some other stuff we found out by having our blueprint tech, Greg, go over the car. So Jason and I agreed to this. I went inside while Greg was measuring it, and I would normally start taking my notes and start writing my estimate and getting it set up. And I would also check the parts that are available, how the parts come, and I have some information on that afterwards. But I came out and talked to Greg to find out, what did we find out on this particular vehicle that has this suede over nose? And so you guys know the facts are lost, the way Kristen always talks about it, is this guy was coming out of like a stop sign, pulled out a little bit, looked, and someone came across the front and caught the edge of the bumper cover, the bumper, the headlight, and obviously the front of the hood, and just took this and did one of these things. Because the bumper's attached, obviously, to the other side, so it swung the whole nose over, it looks like. We have some gap issues on one side, a little wide on this side, a little tight on this side. The door actually made contact with the fender when they opened it. But once again, it's all an assumption. The sheet metal could have just moved, and just this front. But we had a great.
But it definitely points to it, right? So I mean, the swaying over is going to make it do that with the gaps.
With the gaps and stuff. So we had some stuff visually, some anticipation because of the amount of applied impact force here. So I had Greg go ahead and measure this vehicle. He took off some splash shields. The bumper cover was already missing from this job. What did we find? Like, report to me like you would report to an estimator in the shop. Like, what'd you find, Greg? What do we got going on here?
Well, we found some length and some width damage, obviously. we've got about 35 millimeters this way on both rails. With this rail is back about
Whereabouts
15.
on the rail? Because obviously this part's
Okay,
much more than 30.
So we obviously know this is we didn't measure this point. So we measure the lower mounting point for the rad support, okay?
Right, there's a
on
rad
both
support
sides.
mounting hole here on both sides.
Right, so that's a jig point as well. So we were able to measure that in width to find out how much sway we have. Okay, but that's on the lower part. It has nothing to do with this up here.
Right.
Yep.
So we would have to measure that separately.
So
if
you
we
said around
wanted to.
30, I think you said 30?
Yeah, down here.
Down here.
Down here.
Okay.
Down here we got a lot more than
Well,
that.
obviously, I'm going to give you guys a quick little look here. I'm just going to take this, and this is right now where the front of the rail is. It's kind of pointing over this way. This is where the tip of the rail in the dead center is. This big bolt hole there.
Right.
And if I line this up down here, okay, so this is where the rail's supposed to be. So you see from here to here, it's about 200 millimeters
Right.
at the tip.
I'd say
and
so.
this is sacrificial to a certain extent. Jason and I will talk about that after.
Right, it's a bolt-on part. But
Bolt-on part, we expected that, but this down
but
here is
this
over
isn't.
30.
Yeah, and these points up here are not.
Right, that's
bolt-on.
that's
That's
part of
the
the
rail.
full rail.
That's part of the rail.
So we
would
got
need to
30 over
replace
here.
that.
What else went on with this? Like, what else did we find? What about the engine cradle mounting? How was that?
Okay, so the rear or the engine cradle mounting was good. Everything was
It's
good
in the
there.
right spot, both left and right side?
Both left and right side. Okay, there's another pilot hole in the mid-range between the front of the front cradle and the rear of the front cradle. So we checked those points. Everything's good in there, nice and square. No
So
problem. So
basically
it didn't
from
travel too far.
For this front section area here, from my mounting points, the rear mounting points of my engine cradle forward is my damaged area. Tell me what's
Yes.
going on in the back area, because I made you measure everything you possibly could get on this.
Okay, so we didn't find any kick up or anything in the back. We measured a couple of points on the cradle that were factory data bolted, and then we measured the cradle itself, a couple of points just to make sure that there was no damage to the trailing arm itself, and we squared that off on the report. Yeah, it's very obvious to see that there's no damage back there.
Right now,
If
this
we can-
report here we have is
Yes.
the basic undercarriage.
Okay.
Centering points.
So we know
next up
those
gets-
points are normally known to be good points to measure from first start. So we measured those points, and then we came up to the front of the car, and we measured the front of the cradle, and we measured the pilot holes in the center section of the front rails, and then we measured some pilot holes in the middle of the car. So we know that we have a good amount of measuring points to validate from. And then when we were able to measure the 2 points in the back on that trailing arm, I was able to take and measure a datum length, or excuse me, just a length, straight length number from a known point to the unknown point I measured.
Basically, we had a tram gauge that could do length,
That's
height,
right.
and width.
So electronic
and
tram
now,
gauge.
I don't know what I'm doing with this, but on this, on the yellow there, what's the yellow highlighting? I'm a estimator. I don't work on the equipment,
Okay.
so I don't know what to do with this. I need you to explain to me, why do I have black writing and then yellow writing on this report?
Okay, so the yellow writing are the 4 points that we level the car. The numbers are the actual numbers compared to theoretical, which is the actual CAD number.
The CAD numbers that I
Okay.
mentioned. Okay.
So it's telling me how well we measured those 4 points, how close we are to the theoretical. Okay, and then the other points that are in the black are the points that we measured that are with database. And then on the next page.
Next page, if we go to the next screen over here, we'll have a
You're good.
we'll have another measurement here that gives us some dots towards the rear end of the car. Is this?
Yeah,
once
those,
again, I'm
okay,
unsure
so
what I'm
those
looking
4
at.
points, I'm sorry, those 4 points at the back are the base points that I measured with unknown database. I added those points.
Right, you added those.
And then I compared them to, from the left side to the right side.
And we wound up
And
within,
we're
1
within-
millimeter or right on the money.
Right,
So we're
you can
good
see the
there.
numbers right there on the screen.
Right.
It shows you the length, width, and height of each point in comparison to each other. And I can't read it from here, I'm sorry.
Right. Yeah, no. Yeah, it's small. People at
I'm
home
sure
can
it's underneath 3, or do they be in pink?
read. Right. The numbers aren't that important.
Okay, so if they come up,
Well, in this case, because we know it's good.
Yeah,
but, you know,
yeah,
we're
we
not
know they're
reading them out.
good. We know they're good because they came up green. If you look at the screen, you can at the top of the screen there, the center section, you can see the 2 green dots that represents the points that we measured comparisons from the left side to the right.
Yeah.
And they're in green, so that means they're good.
So what we found though really is the front of the vehicle's got the suede, but we didn't find a lot of damage rearward. Is that correct?
Right. That's
Now,
correct.
now one of the questions I had with Larry when we were over there after the measurements were taken was, you know, is this? I mean, I was surprised, right? Because we've got a bumper reinforcement here that's been folded over, right? That ultra high strength steel bumper reinforcement.
Right.
We ripped it out of the end of the rail, and yet on our engine cradle, we're good.
It took a pretty good hit.
Well, you know, so the skeptic in me goes like, how can that be right? You know, like how can we take a hit that hard?
It's like my elbows are the mounting points and my wrist did this.
Right.
In a way, if you want to get a visual of the underside of the car.
So and the reason is because we got that it was hit from the side. It wasn't impacting the front, and I really do think that a lot of it has to do with those sacrificial rail ends that we've seen. And this
they're all bolted in, and this is about maybe 12 inches or so of overhang. And once again, they do have crush initiators on this, fold areas for a frontal collision where the applied impact force is parallel to the vehicle's center line longitudinally, so that the rails would do something like this, the front, and save the rest of the rail.
Right.
Also lessen the amount of the collision pulse that travels through the vehicle. Obviously, based on how fast the car's coming to a stop, the change in delta V would be the seatbelts are good enough, no airbag deployment, which this had no airbag deployment at all.
Or seatbelt deployment.
Or seatbelt deployment.
But what I want to point out is really, I really like that they always have added these sacrificial rail ends, right? Whereas in the past, we had the clap zones in there, but we're sectioning or maybe putting a whole rail in. Audi, I think, was one of the first that had that bolt-on crush cap on the D3, I think it was. I thought that was, I really, when that first came up, like this is how cars should be built. Now we're seeing a lot more of that. So the vehicle manufacturers, I think, have done a great job of maintaining that collision energy management while making the repair a little bit more feasible. Now, now this particular vehicle, the crush caps are irrelevant because the damage is too far back.
Damage in this fashion. This is not how it's supposed to
But if it was in a slower end frontal collision that would absorb that, take those bolts off.
Stop and go traffic. Probably the bumper reinforcement would be damaged, obviously, with the absorber. A little bit more of a speed type collision event. Maybe this would just get a little crushed. You have to change it. Or in a more significant speed type collision event, the rail would actually collapse, and this 12-inch rail would probably be this big, and it would be all crumpled up like you stepped on a soda can or something, would crunch up like that to save the rest of the rail, obviously also lessen the amount of collision energy that would travel through or around the passenger compartment. Now, Greg, we have another one here, and we got these 4, looks like somebody just rounded the bases in the center section of the vehicle, and we have these 2 crosses in the middle here. What type of measurements was this you took on this?
Okay, so I had a side-by-side measurement by symmetry, okay? And then I just did an X just to make sure it wasn't square, because I was just checking the length for the points across the car on each side.
So basically,
we're
not only are we measuring the vehicle, we're also doing 1 or 2 quick measurements here and there just to verify that our measurements are correct.
That's right.
And that we don't have to go back to anything else and say, hey, wait a second, I got 18 millimeters high in the rear. This car was hit laterally. I wouldn't anticipate damage in the rear this significant. What's going on? Let me check this. If these numbers came out good, I might go back and remeasure it. Maybe the cup wasn't sitting right. Maybe I had an obstruction. Previous repair. You know, improper previous repair, let's say.
That's the first thing that would pop up.
You know, that's the things that are going to pop up here. This is why it's so important. Like we talked in the first show about measuring, and we had that one measurement that obviously they didn't even square the section right on the other equipment that they use, not the Celette stuff. And then we had the other shop with the same exact equipment, measured it, and they measured everything, and we saw after the repair a completely different type thing that was stuff that they used that they should have never measured from the begin with, because it was damaged when it was measured and the center line was struck properly on that particular vehicle. And so we went through this basically as my blueprint tech. So now I know, and I'm going to go back to Jason, my manager. He's going to ask me, hey, Larry, what's with that Nissan? What are we doing with it? Okay, well, this is what we came up with. Here's the measurements. This is what's going on with the vehicle. I'm going to make some notes. I'm going to take the PDF printouts from the Celette computer, and I'm going to go into my file sharing through the computer system because we're all hooked up. and I'm going to send it into the folder for the file for this car. So now I have it in there, and then some people might attach a JPEG, because if you can switch these to JPEGs, and I can put it as a file or as photos into my CCC, Autotex, or Mitchell. So in case I have to upload it to somebody or do something with it, that'll come in handy. If we go to our next screen here, now this looks like graph paper with the drawings of the NAJA. That's that little red round thing in the middle there with the measuring arm off of it. And now I have all my printout measurements to tell me where it's at, like more of a graph.
Right. Now what this is, it basically is just a screenshot. Okay, so after I did the measuring, and I went to the report, and I'm able to add a screenshot of both views, okay, or any viewpoint I want. I can change the screen and make it one big screen and just take a picture of it, a snapshot, and then I can put it into the report. That way they can see and that I can validate.
Just backing ourselves
up. Just back ourselves up.
Once again, it goes back to what Kristen has said numerous
proof
times
in the pudding.
Classes. It's just I have my documentation, I have my proof, I'm able to explain what I did, what measurements I took, where they were taken, and what went on with it.
That's right.
So what I had done is, while Greg was doing this measurement, I went on and I took a look at some procedures and some part stuff to be able to give a report to Jason on what I'm doing with this vehicle, so maybe the CSR can update when the morning meeting, the next morning, let's say, she can update the customer and let them know what's going on, maybe even call the insurance company or whatever the case may be. So
let's take a step back real quick, because did we talk about the measurements on the right rail, and we talked about the left? Right. We were going to replace the left because we're off 30 somewhere.
Yeah,
we were off.
They're both off.
30 on this side too. Yes.
So we're putting both rails in, correct?
We have to put both rails in for two reasons. One, even though this is over 30 millimeters because it got dragged over because obviously the bumper's attached. So it's something to this effect where this is the bumper reinforcement. Here's my two rails. If I put pressure over here, both my hands are going to move both 30 millimeters basically, unless the bumper really bent badly, and here it did over here, but it ripped out after it moved.
You got an ultra high strength steel part pulling on a less strength.
That's kind of a glancing blow.
But when I looked underneath here, besides this little bar, this drop down boxed area that makes up the,
to get off my
I guess you would call it the rad support, vertical support here. You can see there's some tearing and ripping underneath here that you guys can't see. So this part here that's twisted is ripped and torn. It's kinked, it's twisted, it's got to be changed.
Yeah.
And that's part of this.
And the end of this rail's here. We're supposed to be here. Yes. We're way over here as well. You can't even see the thing happening.
It goes both ways. So what I did was I went inside and I wanted to see, do I have sectioning for this? So as we look at the next screen, here's a picture of the repair procedure, and there is no sectioning procedure. It just shows me, and we're not scrolling down on this, it gives you a little explanation in the blowout pictures of both sides, but it's all weld marks. I can only change it from just in front of the firewall forward. Now let's pretend this car is not a total loss because of the value of the vehicle, the age of the vehicle, and stuff like that.
So what you're saying is let's pretend it's like a German, is that what you're saying?
No, I'm just saying let's say it's a 2021, not a 2019. And let's say the car's worth a little bit more than an economical car. So let's say it's fully loaded. So this lower rail, the extension, that lower rail and the extension have to be changed from the firewall forward. And we did find that there was issues with this upper rail that has rips and tears to it from all this being dragged over, so kind of twisted it and turned it. Really no reason to measure because it's already torn and ripped, and visually it's twisted. So we're not pulling it. Now, if we go to the next screen, here's some issues I found on the body shop side, the estimator side, the repair technician. And what we have here is we have a bolt-in rad support. Great, that's fantastic. That's going to help me out a lot. No welding needed. I got some plastic shields there. But our next screen that we look at shows us the front structure. Now, the yellow is high strength steel. So obviously 1, 9, 10, 4, 5, 6, 7, 8. Well, 7's not a high strength steel part. All that has to be replaced on the one on the left side, and then all the rest of the yellow on the left and right side have to be replaced. And because we're changing those parts, I'm going to have an apron assembly now, the original one, that's going to be beat to hell by
Right.
drilling, cutting, and all this extra heat added to it by
Exactly.
taking it off. The part's actually not that expensive, and it's more cost effective to change the apron while I'm changing the other parts all in one shot. Now here's the issue. This car's going to go back outside. Maybe a supplement's coming down or whatever the case is. We don't know how this whole was written up, and we're going to wait for it to come in. I'm going to order the parts, get them in, but then I'm going to have to bench it. Now here's the one thing that many people may not realize. There is no pull time on this. I'm going to have my pre-measurement. Because this is a Celette and I'm not using electronic measuring when I put it back up here, we're going to be using the CAMELEON set, which we'll talk about in a minute, but I'm going to be benching it, and I'm going to be using some additional mounting jigs, obviously for the strut tower, when I take all the suspension out of one side and putting it up in there to hold it in place. So basically I have a jig fixture system, universal, that I can actually attach everything to, be able to weld it properly and hold it in place while I'm doing it. There's no glue needed.
Especially
for
with
this.
the whole rail.
The whole rail in. It's just
Yeah.
so
Right.
much easier. So I'm going to have a few different ones on here. So I'm going to grab the other Greg that's with us and Bob here, because they were our techs that set it up. They were our frame bench guys, our structural techs that worked on this together here to put this together. Tell me a little bit about what we did on this particular car, because we don't have dedicated jigs for this. We have the CAMELEON set that we use, and we talked about at the last show last year, and a few other things we talked about. But give us some of the things that we came up with this, and I'll ask you some questions as you go along.
Well, as you know, CAMELEON, like you said, it's universal. We can pretty much jig almost any car. All the database is cloud-based, so we work off of it live, and we can turn parts and change parts and things like that. But this particular vehicle, we did do the rear cradle bolts on the front of the car, and then we went to the back and we did the trailing arm mounting points as well, and then we set up one point on the back of the frame rail as an additional point to support the back of the car.
Now this, by the way, just to interrupt you for a second, I know this is a little bit more elaborate than doing electronic measuring, but I could measure this car with this system too. I just don't get a printout, but I would have, this doesn't fit here or that doesn't
Get the
line up. So
visuals.
this is my secondary measurement. So guys who have other equipment that have electronic, you'd put it on the bench, whichever way you would put it on your bench and attach it, and then you'd have to electronically measure it. In this case, as I build the specs of the vehicle on the bench, I lower the car down, and then I'll see my comparison to what it's supposed to be versus what the actual measurements are.
Right, but a point to make is the comparison measurement, or the measurement that we're getting off the jig, okay? Whether it be low or side to side or length. There's part of the software that you can actually put those numbers into. So there's no math for the technician, but if the slide plate should have been on 50, but now it fits at 42, the technician, all he has to do is click on point number 7, which is this one here, enter 42, automatically gives him the delta, okay? And after you do that to all your jigs, then you can go ahead and print the report out at the end. So it actually does give you another measuring source and another report that you can actually...
So I can verify, let's say this car was repairable, I'm replacing both lower rails and the upper rail along with the apron assembly, and I'm gonna have the big jig system actually fit underneath there for the apron assembly, or the strut tower I should say in this case. I'll get a printout when either one of you two techs are done doing the repair, and I'll have a printout that I can add to my original electronic measuring, so I can just document everything I did instead of just running around taking pictures that all the jigs are in there.
Yep, we can do that, or you can put it, if you have it up on the lift and you want to do another quick measurement on it, you know, NAJA, 5-10 minutes, you can do an end report as well.
Okay.
So yeah, there's a couple different choices here.
So now, if I was going to replace this, because we do have like 6 underneath here already, and obviously 7 and 8 will not line up. We put them in here, they didn't line up at all because it's so badly damaged.
Let's do that.
When I take them off, and I'm gonna put the other rail in there, besides the strut tower one, would I put another rail on this side to hold that rail in place also?
Like you said, we've got one here
Right.
for the end of this rail. We do have another one midpoint back where the cradle is bolted in now. This is half cradle. So there is another one back there. Like you said, the strut tower, that gives us 3 strong holding points there. And then while we're going on, I could go over and build it up, but we have another one that would be placed here, come up, and actually mount to these points here where this crush cap is bolted onto.
Right, which this would be off already. This would be attached underneath.
Correct.
Underneath here to that point, and then we would have another bracket that comes out with this coming up and attaching right to here.
Right.
Grabbing onto that.
Yep, and it would bolt to right where these crush caps are bolted to.
Right.
Is where the jig would bolt onto. Just like the traditional dedicated jig that we're used to. Same application for you.
So I have less. I would have less area of being incorrect by just measuring. I actually now have something that I'm fixturing it or jigging it to this based off the CAD information you have.
Exactly, and a good point is because we're bolting to the frame rail, once we start welding and we have heat distortion, when you're doing electronic measuring, you get done welding, a lot of times the rail's not in the correct place, you have to start pulling again, right? On a brand new part.
Smart, right.
Or if you've got a vehicle that requires some adhesive bonding that needs to be sitting for an extended period of time, again, you've got it.
Same thing with rivets. You're drilling, you're riveting.
Yep.
You know, when you're doing all your drilling, you have everything in place on the jigs.
Yeah.
Then you take it off, right? You denib.
Right.
And when you put it back, it's in the exact same spot.
And it holds in a nice spot as you put the rivets in. There's no sliding, no movement, because you do have holes in both panels that you're putting together versus squeeze type, which you have clamps there, or mag welding, which you do have clamps there and stuff like that. So that's the nice thing about this, is that you can hold everything in place so it doesn't move on you as you're welding and putting together. And as you got it, like, well, here's the last picture of it. The outside rail gets put on separately. It's 2 pieces. So I got the front rail that's attached to the apron assembly. I know the apron assembly is in the right spot because the lower rail was in the right spot and it was bolted in, and now the strut tower is in the right spot. So that's all in the right spot. So now this gets on top of it. This is just a kind of a fairly easy part to put on because everything else is in the right spot. Yeah. It's just line it up and weld away. And I can clamp it in. I can do my resistance welding for the most part on most of this. There's some plug welds on the cowl area, but the rest of it's all resistance welds, which makes it a lot faster, easier, nicer, you know. And if one of these are in my way, you know, these move up and down, right, with the pin that gets put in there to hold it in the right place. I can lower it and pick it back up again if necessary.
So let's, should we build this tower then?
Yeah, we can build this tower.
Yeah.
I don't know that we can get this one in, but we can try.
Well, I think it would be good though is if we can show how it doesn't, so that we can see the comparison and what that visually does. Let
me get this out of your way while you guys are working, and me and Jason are going to talk about a few things while our frame techs are actually working here and trying to get this put together on this. The big thing that I can say to everybody, and we've said this in other classes, and look, I'd love to do a 4-hour class on just standing here doing the repairs and going through everything would be great.
We got time.
Yeah, it would be great, you know, but to keep you guys 4 hours, unless we're actually in a live class where you guys were helping put some of this together, which hopefully one day we can do. Maybe at a trade show or something and get you guys together, just to really get a feel for it. And I'd even recommend it for estimators, because the estimators need to understand what the technician goes through in some cases. You know, these things are easy once you learn them, but they do take time to set up, put together properly, make sure that everything's right. We got a bunch of checks and balances, but the setup time is larger, but that makes your reassembly or repair of the car much, much easier and much, much faster, especially for the fact that now we have, most of this is being resistance welded. There are some plug welds, but everything will be set up and ready to go. And it'll make it that much of an easier, cleaner job.
I think that gets lost a lot, right?
Yes.
Everyone just looks, look how long it takes to set up. I don't know if they really looked at the entire repair process, so they focus on that front end part and not recognizing all the benefits on the back end. Like I said, just holding the parts in place. I mean, if you're going to put a rail in by yourself, like how would you do that without?
I've seen, how many guys out there have seen a vehicle in the shop, light collision damage, nobody wants to measure it, they're going to pull by eye or a tram gauge, and then they have to go send it for a wheel alignment because they were told, hey, we got paid for a wheel alignment, we got to get a bill for a wheel alignment. Now they do the wheel alignment, the wheel alignment guy says, yeah, but the strut towers are off, I can't get it to align. It's more than 3 degrees, I can't align anything.
Yeah.
So outside of drilling holes slotted in the strut towers to move the upper struts around, you can't do that. No, you're not supposed to.
It's like net form of Pierce, right?
Yes. You can't do that. So now, what do? Do I take a perfectly repaired car? Now, once again, when do you send this car for a wheel alignment? Before you paint it or after you paint it? before or after you reassemble it? Well, the car's basically all done. I'm only going to probably buff it and clean it.
Yep.
Now, I'm going to put a perfectly good car back on the bench again?
Well,
to do what? Try and pull it?
And I think that, and I think you can take it a step further even, right? So you mentioned wheel alignment, but now what are we doing on today's vehicles? All these ADAS calibrations and aiming. It starts with the structure's got to be right.
The car's got to be right.
The wheel alignment's got to be right, because if the structure of the wheel alignment is, that doesn't really matter what you're doing the calibration.
So much of the ADAS stuff counts off of the steering angle sensor or the yaw rate sensor in the steering system, and especially for the fact that most cars nowadays have some sort of electronic steering that's involved with them, especially for lane departure. The car goes off a little bit, but the wheels automatically shove you back over again because the cameras are working with the steering system, you know. And you got to remember, these cameras that are in cars don't actually see what we see, like our vision. It sees numbers. And it changes these numbers, that pictures into numbers, and the car reads numbers and go, well, we're 12, we have to be maximum 5, so we got to go back this way and turn it back, and the wheel's going to push you back into the lane. Some people find it annoying, some people find, hey, this is great to have, you know, but this is that whole system that works together. And if something's misaligned in this front structure, we're going to have a massive problem, not only for wheel alignment, but drivability, driving, tire wear. I don't know how many times we've gotten, Kristen and I know you've been involved in a few of them, but Kristen, myself, and Mark, we get significantly worn tires, either on the inside or the outside areas, or chop up of the tire, or feathering of the tire. But I'm talking like, not a little feathering where you got to feel with your hand. I'm seeing, you can look at it and see it's all feathered. And it's like, well, that's not related to the accident. It could be. Let's do some measurements and find out what's going on.
Well, just look at our vehicle here now. Granted, this is like greatly exaggerated. Like we're way to the right? But maybe it's when we put it back there. Maybe it's not all the way where it belongs. Now we're going on the vehicle like going on the road at an angle, right? So we've got those cameras, we've got those sensors, we've got the wheel. You're fighting tire issues. You're fighting the ADAS system. If you do calibrate it, now that isn't in sync with it, because again, it'll calibrate likely.
Well, your toe's going to give you the most wear, and what people also don't realize, if your toe's really off and your SAI is off, your scrub radius is going to be off, and that's really going to give you a lot of problems when you steer a turn. Forget about going straight. Going straight, the wheel's going to be like this constantly, fighting. The geometry of the steering system is going to be way out of whack. And, you know, you have all this stuff in the front that's pushed over. You know, it's just not, you know, years ago we had the longitudinally set in motors with the fan connected to it. And, you know, we would hear the fan hit the shroud. It's like, oh, something's wrong here, you know. And nowadays we don't have that anymore, really. So now we have an issue where you're going to have drivability issues, maybe not so many mechanical issues, but you're going to have electronic issues on some of these cars. And that's what techs need to understand. That's why it's so important to do a test drive. I mean, you don't have to do a test drive, I'll be honest with you, because the customer will do it for you.
Well,
you know,
well,
and then
especially before that. And I got to be honest with you, you said scrub radius a little while ago, and I had to throw up a little bit because I just haven't heard that term for a while. That's something that's all I've never been able to put that whole scrub radius.
Well, the scrub radius.
I don't want to hear about it.
It's the opposite. It's the opposite of the SAI at the bottom.
It just gives me the heebie-jeebies.
You know, because as the tires run down the road, they're constantly doing this, even though you're holding the wheel straight. Because the toe is the worst wearing angle. As you make a turn, the car's going to do this a little bit. For those who are into cars, if you had a Detroit locker or a direct posi, the car hops around the corner. That's what the front's doing now. So it's scrubbing across the ground laterally, not longitudinally. So now this becomes an issue where you get a lot more tire wear, you get the feathering coming in, and it just becomes an issue for drivability. You know, and it's amazing that a wheel alignment tech who really knows what he's doing can tell you what's wrong with the structure.
Sure.
Because years ago, iCar had that whole list of SAI, camber, and caster, this, and this. Only this part, or the structure's bent. So if in this case, you wouldn't anticipate any suspension damage because nothing got hit on it. It was a low-speed hit across the front. So what's off? The structure. And I'm sure some shops or some people might feel, oh, I'm going to change this rail. I'm going to weld and fix the upper rail, the hell with it, and I'm going to pull this rail. Well, if you don't measure it and don't pull it right, and you're pulling it to just make the bumper reinforcement fit on, it could still be swayed over, or you have the bad tendency of, guys have a tendency to over pull back the opposite way. So now I actually induced damage the opposite way. So this is over 30, let's say. This is over 30. Now I'm going to actually put it back the opposite way towards the left, maybe 15 millimeters off. which means now to get this bumper to line up, I got the other thing off 15 millimeters. So now I have a whole issue where now I got a car that I actually I induce sway into the opposite side. Some of the older techs, I know you'll remember this, and the newer techs may not realize this, but
you call me old?
Yes, I did. Well, we worked on full frames back in the day when they were all mild steel, and we would get a lot of diamond and twist. And what would happen if you didn't check the car the right way and you try to pull diamond out of it, you sometimes induce diamond the opposite way. So if I had a rear with diamond on it, I pull it, I pull it, I pull it, I pull it, and all of a sudden if you didn't measure it and you find out afterwards, I actually put diamond going forward now because I over pulled it the opposite way. And now it's just and most frames nowadays you really can't pull because of the type of strength from steel. No, it's you know, that's the problem with them now. And
just give me another flashback, by the way, when you mentioned the full frame. I remember the full frame pilot class in New York with Bo and Luke Duke. Anyways.
Oh, Luke Duke, yes. That was a good time.
That's for you, Goodson.
And by the way, we had, that's for Jerry Goodson. Remember, we also had our butler service. Remember?
Oh, man, oh, man.
Al Fierro had sponsored the thing at Fierro Mandero at the time.
Oh, that was where's Al Fierro? I didn't realize. Okay, I never put that
Fierro shop.
Okay, awesome, Al.
So now it's called Fierro Auto Body. Okay. And Ali actually had white tablecloths. Butler service.
We had a spread, man.
We had a spread and a half. Yeah,
it was the nicest.
Thank God we ate a little bit towards the end of the class because after that everyone was ready to pass out, and you know we all put on 20 pounds with all the food. You know, no, have another bowl of pasta. It's my 9th bowl of pasta. No, another one. You look hungry. Yeah, I look malnourished. That wasn't that funny, Jason. That's a little hurtful.
Well, I'm not exactly. How are these guys doing over? How are we doing over there?
Okay, we're just about there.
Awesome.
So that what would happen now? I have my estimate, I have my information. During this repair process, I might come out and take some pictures of this or have the techs take pictures of this. Why? Well, if you have X amount of time to set up on a bench, because years ago I wrote an article on who came up with 2.0, doesn't exist. So whatever time you're coming up with, and we're not telling you what time to put, but you know,
well, I think we've exceeded that today.
Hey, we exceeded that. But you could show the video of what these take. You could also do your own time test studies. Guys always ask me, Larry, how do you have for your clients, your shops you deal with constantly, why do I see this on their estimate or I see this amount of time? How did they get to that? Well, it's a long process. And it was ability of, here, I got a videotape to prove it. Here's the videotape. You tell me when you think the tech is like slacking off or taking breaks or whatever. We have time test studies to show them what went on with these things, how they were built, how they went through, what went on, and the process of it. You got to remember, each one of these things takes X amount of time to build.
Yeah.
And then you got to put it underneath the vehicle, and you have to line it up to the vehicle. And if it doesn't fit, I could possibly on a repair,
I'll take this out of here.
Literally, you know, I'm lining up my rail, I'm putting it on, and you're helping me out here. This may have to be like this 2 or 3 times. It may even, while it's tied down over here, because this is the front piece that goes over here, you might have to do this a couple of times. And then put it back in again, and then have us put the pin back in, then put the bolts back in here again to make sure they line up the right way, take a picture of it. So this could be 3 or 4 times. This blue jig is going to sit on this base and stay there. Okay, but the upper portion of it is going to come on and off a few times, will be dropped up and down. I might have to bolt it in. I do all my welding on the side, and now I get to the front, and I'm doing some welds, but then I can't reach over here with the, well, let me pull this out, and now I can get my resistance welder or a mag welder, torch, or even my arm and elbow to get underneath there and try and weld the spot that I have to do. So, I mean, that's the important thing for you guys to realize. The estimators have to come out of the office sometimes and watch what goes on with this. That's why I'd love to have estimators in a class and have a Celette here. Let them set up a dedicated fixture system. Let them set up, even if it takes 6 or 7 of them to do it, like we do at Benz or Porsche or anything like that. Go ahead. Where we can actually be there and everyone helps each other, but you learn how to put it together and you say, hey, wait a second. Now I see why this takes this time.
Let's tie that back to yesterday, our estimating conversation that we had, right? So they need to understand that process so they can write a more effective estimate, right? So if they've done it, and they've seen it, and they've watched it, and they explain it, they've got that justification. So every line item, like Kristen was saying yesterday, we can justify every line item because I understand what it takes, why I have to do that. I think that's a great idea. Is that we do need to get the estimator out of the front of the shop, get them in back, and go. We're not asking them to repair the car, but like go through this process and see what it takes to set these up so that you have a better understanding of it, so you can write a more effective estimate. And again, like we talked about yesterday, make the shops more money.
and an unfair advantage for me being at certain shops. When a client of mine, Mid-Island Collision, bought the CAMELEON set to have it in there and brought it in and stuff like that, and you know they tried it out. I tried it out to be able to do it, and then I was at another shop one day, Exclusive Auto Collision, and he was trying it out also, and I got another training session on it. Now I have an idea to say, hey, look, so now I can walk up to a CAMELEON set and not building it off of what the specs are, but I can say, look, you got to go into the computer, I'll show you the build sheet, but here, and I'll just grab any one of these things out of the drawer while I'm talking to an adjuster and go, well, I got to put this on here, this has to slide and line this up, I got to tighten this up. After I'm done with that is, I put the blue tower on here, I tighten those up, I put those down, nothing's put on with an impact gun, you hand tighten everything, and then I got to get the right tower on here, and then I got to go ahead and I got to put the right MTZ at the top here and put that on there. And he's like, that's one.
Yeah.
There's 12 that have to go underneath there, and they look, what? Yeah, I got to do this 12 times. How long did that just take me? Oh, I'm not sure. All right, well, look at your watch, and I'm going to build another one right now without going into the computer system and just telling you what it took me. Oh, I see. And the reasonable people will understand because I was able to show them what was going on. So I see that we have our jigs in here, and I'm going to turn around. Yes, I'm sorry about that.
What we did was we went into the software and we switched from a 140 tower,
right,
140 millimeters high from base to the center of the hole.
Okay.
And that's what the software called for, but because this was hit, we couldn't get it underneath to take a good look at it. So we went into software, we picked an 80 millimeter tower. Allows us to pin it at a different height now.
Right.
And now we can see here where we're off. So if you look under there,
all right,
I think
so
we're probably...
I'm going to try and show you guys as best I can. Which camera is my best one? That one right there. Okay, so here is the point here with my finger, and I'm going to take my thumb and just put it to where the center should be from center to center. That looks about right. So
hey, it's about 30 millimeters.
So here's the center of this chrome piece here at the tip, but that's supposed to fit into that hole. And this is where the hole actually is dead center. So you can see here we're about 35 millimeters off by just a guesstimation here. But I mean, that's off. That's pretty bad, that's there. Now this one here, I saw that we have a plate that we put over here, and then this would come in this fashion here, just to show you guys. I can't get it in here because this is in the way. But you can see this is where it's supposed to be, which means this is going to be right about here. So you can see the distance that this is also off. So this wouldn't go on right away. I might build it, put it up here and go, okay, snap a picture, and now I'm going to put everything, take this off, and I'm going to leave this one here, the two to the back here, the one that's going to be where the suspension came out. That suspension's probably going to stay in. I'm not going to have to move that, but I do have to cut out the bottom rail, okay? So I'll have those three underneath the other side, so I'm able to line everything up, be able to weld it in properly, and like you said, I can get a printout afterwards of all my measurements that we're good to go, and I'll even back it up with a picture. You know, so now I have everything that I need there. Now, how long do these take to ship to me as far as when I have to rent them?
So there's no renting involved because one set of jigs in these two toolboxes, and you have everything on hand.
So I don't get the gray box that comes to me anymore by RPS or trucking or something like that. I don't.
No.
No.
You missed that whole part.
Well, I know you said they were universal and stuff, but so I can get this, and now basically within a few minutes of just walking across the room, I can bring it over and have it there. I don't have to call somebody.
Correct.
But I can still rent dedicated jigs if I have to, right?
Yes, sir.
Okay. So I still have the option to rent dedicated jigs, but for jigs that you're not making, we have the option for dedicated. Or I have two other cars that are on jigs. I know I can't get another set right now, and I need a third set. I can just build this.
Correct. And you know, years ago with Sentra, we probably never built jigs for Sentra.
Right. Yeah. Now you've opened up to American vehicles. You've opened up to Asian, and of course, you've always been popular with the Kristen-hated word European, the European market.
Well, last year we did a Chevy Malibu.
Yeah, we had the Chevy Malibu up here. Yes.
So yeah, we're on the GM program, we're on the Ford program, Toyota, Lexus.
But you also had, if I remember correctly, you do have dedicated jigs though for the F-150 still.
Yes, for not for the newest one.
Not the
that's
newest
going
one, but the older
Chameleon.
one, right? Yeah, the
And
15 that came out. I remember that. That was a
Right.
big thing. First time ever that Celette had dedicated jigs for a pickup truck.
Exactly.
Because Benz doesn't make one.
Right. Yep.
At the time.
Yeah.
So that's
Yeah.
that's.
So even the new C8 Corvette is it's approved for Chameleon. We didn't do dedicated jigs for that one. GM wanted to go with Chameleon.
So you'll still make dedicated jigs for manufacturers who want you to, and then other manufacturers will allow the Chameleon to be used, and then you get that program set up for them. And
Correct.
now, how do I get my build? I know when I usually get my MZ Plus, I get my build sheet in there, and I get all my information in a little plastic packet, you know, and it's laminated so it doesn't get destroyed. What, do I get like a booklet with this that has all the different measurements for all the different cars?
Everything is online, so it's instant updates, the newest measurements. Everything is right at hand. We've got it pulled up here. I don't know if we can get a good shot of it, but it's very interactive software.
We can walk a little bit closer over there so
So
we can show it.
we're able to actually
Stop
spin
right there.
MZ towers. As you heard us talk about earlier, we changed the one from 140 down to 80 so that we could get around some damage. Same thing if there's maybe a trailing arm in the way.
Right.
So we can drop the MZ tower, we can get a longer extension.
And adapt around it so you can hold it in place.
Right.
So just for people who don't have a Celette bench there, I'm trying to get the glare off it. Okay, so people who don't have a Celette bench, obviously the red bench, and I'll go with colors just to make it easier. The red bench and the silver top of the bench is a machine planed level area.
Correct.
Now, these silver, like 2x4 looking things or 2x6s that run, I don't know, laterally at the front and then seem to run across, longitudinally at the front and laterally across the rest of it. What are those called? What are those?
We call those cross members.
Okay. And what do they actually do?
Well, the whole bench is drilled at 100 millimeters.
Okay.
So the surface of the bench is drilled every 100 millimeters. That allows us to slide the cross members back and
For different
forth.
vehicles for
Right,
my
so,
setup points.
so you see here we go one,
Now it's
and then we go up, and depending on the length of the bench, depends on what the
That's how you
last
measure.
number is.
And my
okay?
build sheet will tell me where to place those as
Exactly.
it goes.
Yeah,
Okay,
so the
now-
front ones never move,
Right.
and then the ones going across the straight ones will move depending on the vehicle platform.
So if I work on if I worked on this Nissan
Too far out of
and I
range.
took it off and I go to put another Nissan on, do I move anything?
You'll move some of the straight ones, and
Right.
maybe you won't move any. Maybe
Same
you'll
exact
move.
car, just put it back on, and it saves me a little bit of time that
If
way.
it's the same car, yep. If
Right.
it's a similar car, it might be in the same spot, or maybe one is moved.
Okay.
Now
But the
years
throttle
ago,
told me each time, right? Years
Exactly.
ago, everything had to be
well,
moved.
years ago they were steel, right?
Right.
So now
And they were heavy. They were aluminum now, a little
now
bit
they're
easier.
aluminum, so everybody's loving the.
Much like the side gantry, a lot easier to lift nowadays.
Correct.
Okay, so now, unlike those guys who work on Celette benches, seen it before, normally you would bolt the blue towers directly to the cross members.
Right.
In this case, with the Chameleon, we're going to bolt, what's these gray pieces called that seem to have slide in, out, left, right, up, back and forth?
They're a sliding block.
Sliding block, we're calling them.
Correct.
And that's going to lock on place to give you some universal ability that it's not dedicated to that spot.
Correct. Yeah. So the MZ tower was easy to bolt in every 100 millimeters because when we made the jig, we made it to reach from that spot to where the car had to be.
Right.
But with the universals, we used the slide plate to go length or width to make somewhat of adjustment to get to that point.
Okay, and now then we put our blue towers on,
Right.
and then we have our riser tubes,
Yep.
which is like the chrome round
Pistons.
tube,
Pistons,
the piston
yep.
that goes up and down. That we have the pin in there, and the system's going to tell us if it's in the first hole, second hole, or in some cases a longer one with a third hole.
Right.
Which hole it's going to go into, and then we have these red or silver pieces at the top, which are the MZ Plus on the normal Celette. Are these still called MZ Pluses?
No, they're called UP plates or universal plates.
Universal plates. Okay, so in place of the MZ Plus that you guys know about, now we have something that's called a universal plate that goes up there. Okay, and then you have, unlike the MZ Plus that usually had a dedicated welded round cup or holder with a bolt hole in it.
Right.
These seem to look like they have another bolt on it that I can adjust up and down. What's with
So
that?
that's the AD adapter. And,
AD adapter, okay.
They start at 35 millimeters and they go up from there. 5 millimeters, 35, 65, 120. So it allows us the height to come up off the universal plate.
And once again, this system will tell me exactly where I need to set that, and then I can make a comparison to what the vehicle is versus what the specs are supposed to be.
So on top of that adapter, then that's when we actually put the socket that fits the vehicle, whether it be a hole or a bolt.
Okay. Well, that sounds like a little bit easier of a system. We're done with this. A little bit easier of a system to move around the shop to have it. I don't have to wait for a delivery, or it's backed up, or hey, look, we only got 4 sets out, and they're in. I remember one time, what was it? The old BMW Graph, the 53s.
Yep.
I know they just came out, and it
E92.
What
was it? E90? No, not E92.
E92 was it? No.
The aluminum 60.
E60.
E60. Started with E60, yeah.
E60, and they just came out, and we had one, and we needed it, and guess what? Well, they're at the trade show. Well, we'll get them to you as soon as the trade show's over. It was at the same time as SEMA, and they just came out. There was like 4 in the country.
Right.
It's like, well, one's rented out, and the other 3 are at the trade show. It's like, oh boy, what do I do now?
So that conversation kind of relates to a question that we got that came in.
Okay.
Kind of about coverage. You know, we talk about universal. How universal are we talking? Like, are there some gaps in coverage, and how frequently are we
Can I put my
updating?
71 Cadillac on here? No,
Possibly, but probably not.
Possibly, probably not.
Now, but it does bring a good point, though. If you want to put your 71 Cadillac on here, so you could actually build some jigs to hold that car in position while you work on it. So you could actually build up to the car.
So if I had the old 1971 measurements that gave me what it's supposed to be, I could adapt this to actually fit that on here if I wanted to.
Or you could do it yourself by measuring between the 2 holes and starting out with 2 jigs.
Right.
You know they're square on the bench. Move forward and level the car to whatever datum plane you come up with. But you could have solid anchoring on a car like that, be a full frame with a unibody on top of it, and be able to actually pull on it. So it could be universal anchoring as well.
Now, what about
without data?
What about some newer vehicles? Okay,
so let's go to 76.
Okay.
How far back?
So you see here, like we
how
said,
back would you go?
we have
19,
the Nissan.
2020?
I mean, on some of the cars that we built jigs for, we go back.
Well, I know the jigs, but the universal though. How far back would this?
Well, what I'm saying
Nissan
is, if we built jigs, for 1970, 1960, car, it's in there.
You've got the
so
data.
I can take an
so
old S-Class from the 60s. Well, what was it back then?
65, 64, I think.
Right?
Yeah.
Greg would know better.
Maybe even 63.
But those older ones.
Yeah, that'd be the one, before the 116 chassis.
The 116. So I could put a 116 on here because I probably can't rent jigs, or somebody probably out there has an old set with dust on them. So I could actually put a 116 on here with the database because you made jigs at one time and you universally made them work.
Correct.
Oh, cool.
Now, there might be some holes that you can't get because those old cars had some big holes.
Yeah, right.
And we might not have adapters for them, but you'd be able to do a lot of it.
Okay. So if I have something like this Nissan here, how far back is the system? This is 19, so we have it in there. How far back does this go? 17, 18?
Yeah,
I know it depends
I'd say
on the vehicles.
Like you said, depending on the vehicle, but 15, 14, 13.
Like I would assume my Dodge Durango, which is not really changed except for the grille bumper cover, because I just bought a 2021, which is still
keys, different keys too.
Well, no, different keys. It's the same one as the 2012. And basically, it's the same doors.
Right.
They really haven't changed much. They changed the
facelift on the bumper.
The
lights
bumpers
and stuff,
changed.
right?
The grills changed. The taillights changed. The tailgate, because of the way the big light goes around across the back. But basically, the doors, the quarter panels, the fenders are all the same. The hood's changed, with the different type of hood.
Same
so
platform.
Basically, if you have a 2021 or a 2020 Dodge Durango, I'm going to assume that most likely it goes all the way back to at least 13 or something like that, because it's the same.
It does.
Platform, yeah.
Same platform.
Right.
So that's good. But if I had a changeover, let's say it changed in 15, maybe I only have 16 to 20 in that case. But you'll have it in the database that you'll show what you cover.
Exactly. And sometimes, if you call us and give us a couple days, sometimes we could pull the data and actually go ahead and
build it out.
24 hours. A lot of times they'll be able to turn it over if we
Well,
could pull the data and upload it on.
You don't measure cars. You use
Right.
the CADs. So it's just
right.
basically taking, if you can get the information from the CAD,
Right.
you can put it into your algorithms or whatever numbers this is and plug it in, and
Right.
automatically it'll populate all the numbers, and they can send you a build sheet
Right.
which
Right.
is nice. And they're not building jigs; they're just building the I guess you would say like the blueprints.
Yep.
You know, for like a house. Here's the blueprints. Here's all the measurements. Now go, go do your measurements.
And speaking of that, I want to tie it back to a video that we did a while ago. So if you're interested in learning more about this, CAD versus the measuring of the vehicles, Bob and I did a show a while ago on that. So I thought it was informative to me. I was very enlightened as far as all the different changes that can take place. Or if I measure a vehicle versus the blueprint, the CAD drawings was pretty remarkable. I thought that was pretty cool. So definitely check that one out. It's on the Collision Hub YouTube page and Celette YouTube page, and check that one out. But so while you guys were talking about with the laptop, Greg was back here doing some work, and we now. Did you repair the car? No, we got this fixture to fit.
No, I just
so
wanted
that's
to
what
show you how to
about
measure.
before the measuring about like taking your measurements and you can put it in the computer. So Greg, you want to walk us through what you did with this to kind of get it to fit in the hole?
Well, what I did was I just set the length, I loosened up the sliding block,
Right.
and I set the length and the width to enable me to get the adapter up to the bolt. And then I set the bolt height up, so now I'm being able to measure my height, my length, and my width to put into the report to show how far off it is from theoretical.
So
and where do those
technically,
numbers
I
come
kind of
from?
like no different than if I electronically measured it right now.
That's
I
right.
now have measurements.
That's right.
But I got to physically read them.
That's
So
right.
how do you get them? Yeah, so walk
Okay,
us
so
through
then
that
I go
process.
through the software. I'm going to let Bob show you how to put it into the program, but you can do that easy enough. You can actually take a picture of it and put it in with the software as well.
Okay.
But the software will allow us to control and save all the data for each point.
So
Okay, whether it's good or bad.
the database system gives me my measurements of whatever they are. It didn't fit. We showed that, and the pin had to be out.
Right.
I took a picture of that. Let's say.
Right.
Okay. With the measurements, I can see it all.
Yep.
Now I offset it to
Right.
where it actually is.
Yep.
Once I line it up, I can now, besides putting the numbers in the computer, I can come over here and do one of these things.
Right.
Take a picture, have the numbers where they're at,
Yep.
and show a comparison in
Right.
my estimating system. Here's the measurements where it's supposed to be. These are the measurements it actually is, and here's a printout that we can go ahead and put on here
Right.
to be able to show
Documentation.
Here you go, documentation. I don't have to throw the electronic measuring system underneath here again.
Right.
I have the
That's
ability
right.
to go ahead and do that.
So you can do it before and after.
So that does come in handy.
Because you have the pre-report, and then you have the post-repair report.
Now, I know there's always training with this type of stuff and things that matter.
Yes,
now,
sir.
do you offer like a day training class, or when they buy the equipment, they come in and train you that day, or they rather have you out of the shop situation, not be bothered, and you have a training course?
So we adapt to the customer. It's usually much better if we could get them into our training building.
Right, always, but yeah, out of the shop situation.
Undivided
Right.
attention.
In a
Yeah.
lab, yeah, you don't have to worry
Yeah.
about screaming and yelling and running around
Yeah,
doing stuff.
and for a few reasons, because one is when you're there training, usually there's other techs, jumping in, the painter, he wants to check it out, and the estimator comes over and he's asking a question to the technician, so you have those interruptions. And when we get them into the training center, it's full on, no interruptions.
How many people usually have in a training class? Like the max amount usually?
Greg could probably answer that better, but
There's
I mean-
ideal levels, and then there's overload. You get too many people and things get out of control. So myself, I like to stick with 2 to 4 people.
2 to 4 people. Because like I know when I go to Benz, Audi, Porsche, I remember Greg used to be my instructor for years with Benz, and we'd have like 8 people in the class, and then
Right.
he'd break us off into 2 teams.
Now that's possible too.
We look up procedures, but Greg also knew the people who came there. So like a lot of times myself and this other guy, Carmine, and Jimmy would go together, and we would be like split up. We couldn't work together because he put us with other people so that he knew the guys that didn't know so well, so we would help them out. Like
it's good networking too, though.
Yeah, it was networking and stuff. Like Carmine's excellent with the Celette bench, so he might be helping a couple of guys with the Celette bench, while I'm helping a couple of guys with the Whiz program, along with Jimmy, to try and find it or figure out the information
Right.
and stuff like that.
Right.
And we all work together to explain it. But every class that we did, we would have to go ahead and build the bench. And we'd all put the body in white on. So every
Right.
class you did it, even if you knew how to use it, okay, yeah. The instructors, the guys who knew how to use it, okay, you've been through this enough time, let these guys do a little bit more, and then
Right.
we'd help put it on, we'd take it back off, we'd take it apart. But that gave you the basis of knowing, and every class you had to look up the repair procedures. That's Benz, Porsche, Audi, every
Right.
one of those classes, you look it up, you work as a team, you learn, and that's what gets beat into your head. And that's nice because you're there 2 days, Once in a blue moon, it used to be 3 days.
Right.
But at least you're not in the shop situation being bothered constantly.
Right.
You're able to concentrate, which is why I've said I'd love to get guys here for like estimators for a class and do like an estimated version of this. Let them tinker around and play around with it. Just understand it. Yeah, that'd be great to have a class like that, so that they get now I understand. Now
Well,
I can physically do it. I can't do it for a job because I'm not good at it. But now I understand and get to ask the questions of you guys to hear it right out of the proverbial horse's mouth. Not hear it from us, but hear it from you guys. Hey, this is what we have with this.
Right.
So it's a nice system to adapt to multiple shops instead of what used to be just European shops had the Celette benches at one time. It's really most of the people had it.
Right.
And so this is a nice little change.
It's awesome.
And like I said, if the shop wants training in their shop, we show up and we do it on site.
Cool. Beautiful.
I did pull up the report.
Okay. We might have to carry it back over here for a second. I'll give you a hand with that. Oh, you can zoom in? I'm sorry. Okay. They can zoom in. Just tell me if I got to tilt it a little bit. Good there? Okay. So what do we got going on here?
So what I did was I clicked on the report icon up here. Looks like a page of paper, and it pulls up the vehicle. You can enter all the vehicle data in here: customer
name,
mileage,
the tag,
RO,
insurance company, claim number, stuff like that. Okay, cool.
Just like a regular report. And then over here, if we have any damage, what we do is we just click on XYZ, whatever the damage is. So X being length. We click on that, and we just take the number off the slide plate.
Right.
Whatever number the slide plate is on.
And we just put those numbers in.
We just pop it in.
Right.
That's all we do. So there's no calculator, to figure out the difference. The software does it. Jigs that are good, we hit the check box, and that just populates
the factory
dashes.
Number. Right.
Everything's
dashes.
good there.
Good.
And then at the end, we just print a report. And then we've got an actual damage report off the CAMELEON software.
So basically, an estimator inside the shop, if the technician's using this portion right, puts it in the right folder file, I can walk over, save it, put it into my system, and I can upload it to an insurance company, email it to an insurance adjuster or something like that, or plain and simple, for documentation purposes, keep it in my folder for that particular vehicle electronically. So now I have proof. If I ever have to go back to that vehicle, I know exactly what's going on, and I could always explain anything.
The other thing I just wanted to
Sure,
point out,
anything we didn't point out yet. That
all the adapters all have a place to go back to.
Well, what's also nice is, and maybe guys can't see this in there, but there are multiple wrenches and Allen keys that are for this, so you don't have to run to your toolbox to get your tools. You're here with everything. The only thing you're going to need is your regular hex head bolts. You're going to probably have some sort of a system for that. Once again, hand tools, don't use impact guns on this stuff, and it doesn't have to be cranked down. Okay, so you don't want to do anything like that. And there's all the different adapters in here and stuff like that. And everything's marked and
everything's labeled.
Got little hole punches in it, so you really can't put them in the wrong spot.
A place for everything and everything in its place.
Right.
All your bolts, everything that you need, adapters, everything is in one spot.
The only time you need to use a bolt with this system outside of these boxes is for the MZ Plus piston, which is in the piston box.
Right.
So when you grab a piston, you grab the screw. Everything else is in the box.
And guys, I can only tell you this much. Because you have so many nuts and bolts on this, no impact guns. If you have an electric a ratchet or something that you're using, or even an air ratchet, put a regulator on it or turn it down to the lowest.
Right.
You just need to go brrr, just run it down.
When it stops, that's
when it
good.
stops, let it be on level 1, let's say.
Right.
Just so it stops. That's all you need. And then if you just take a wrench and just you're not pulling heavy. You're not lifting the car off the ground with this thing.
Right.
So you don't need to crank down and stretch these bolts down, because they are expensive, the bolts to replace.
That's
and
right.
the other thing too is, if you're working on just a pinch weld frame machine, you're holding in four little spots, that are very weak and never meant to pull on. Once you put a couple jigs in the car, you already have more holding power without even tightening everything.
That goes back to
like a gorilla.
The Dodge Dart and the Jeep Cherokee. They
crush the
told
rockers,
you can put it up in the air and hold it by the pinch weld clamps, but you cannot pull the vehicle. They even tell you don't crank down on it. But most of the Porsches and the Volkswagens, you cannot put pinch weld clamps on some of the vehicles that have pinch welds, because they have bonding adhesive, and they found if you put the pinch weld clamps and tighten them down, you'll damage or fracture the actual lap shear holding strength of that adhesive, which yes, will affect crashability, but the bigger issue is that it doesn't get into a crash. You're going to get all the rust in there because that's what's actually sealing out the area to prevent rust from getting in there.
Keeping the air out.
A whole bit, there's a lot of science involved in this, and I have a tendency to sometimes talk too much engineering and over people's heads with some of the science end of it, and I don't want to dumb it down, but I want to bring it down a little bit lower to say, hey guys, look, you got to look at the science of this. For some reason, everyone seems to be hot on like we're going to talk tomorrow about the ADAS and the electronics. They want to do because it's all computer and press a button and hit a target. I think this is easy. There's a lot of electronics involved that they don't realize. Well, guess what? We have to realize how much mechanical engineering goes into this stuff. But then now, years ago when I started, we didn't worry about chemical engineering. Now you got to worry about chemical engineering with all the glues and adhesives, structural adhesives, non-structural adhesives that are involved in this. Forget about foams. So this is a whole big.
You made
issue.
You made a good point with that yesterday about leave the ADAS to the dealership because there's just so much technology.
There's some
here,
really good mobile guys that are electronically knowledgeable.
For sure.
Like you were talking today about the hybrids. I mean, most guys don't want to screw with that because it's so hard, the electronic. That's basic electric.
Yeah.
That's easier than the ADAS. The problem is there's no computer that you can press a couple of buttons and a scanner that hit a button that can diagnose basic electronics.
Right.
But you get an electrician in here, he'll be over there with his fluke multimeter going, okay, I can tell you what's wrong with this. That's the problem.
Yeah, that's it all starts with structure, like we talked about.
Yes. That's the foundation of everything.
Structure, the wheel alignment, the ADAS all fits together, and I think this is a great solution. And we love the CAMELEON and how it works, and it's a cool tool, which is a good segue.
Well, do you have any more questions?
Tomorrow.
No, right?
No, we don't have any questions.
Oh, beautiful.
No,
That's great.
I mentioned cool tools. I'm going to go right into tomorrow morning. So
we're
going to wrap for the day, and we got some more work to do. We got some cool tools we got to set up. But you guys are going to be back tomorrow at 9:30 a.m. or maybe they'll still be here at 9:30 a.m. depending on how things go. Right? We're going to talk about some of the cool tools that you guys. Some welders over there, or some other dent pulling and stuff over there. So
welders, dent pullers, plasma
induction
cutters,
heaters.
induction.
Cool.
Yeah.
So we'll be back tomorrow 9:30 a.m. With the Celette crew. And then at 11, performing ADAS calibration research, we've got ADAS Think and Aztec here. So we've Nick's already here. I'm not sure when Jake's coming up, but we'll
Jake
be here.
will be here with his
and
socks.
we've got some interesting stuff to go through tomorrow. So we've been doing some bumper repairs the last couple of days.
Oh, it's horrendous. I fired Jason 4 times already. It's terrible. It's like Stevie. At one point I even asked him on one of the repairs, did you even keep your eyes open?
Well, I put it on my tongue. You told me to put it on my tongue.
You lick it on. Yes, that's.
And I used adhesion promoter before I put the body filler on.
Right.
So I'm ahead of the game.
A little bit of bubble gum works perfect.
So 11 a.m. with ADAS Think and Aztec, and then Aztec will be back at 2 o'clock. We're talking about in-house diagnostic calibration for collision repair. Because again, we still need to keep beating that drum because it's still way over our heads. Like I said, we have enough troubles with welding and structural repair. We start taking ADAS and EV and hybrid. Well, man, forget about both. So there's a lot of education. And then tomorrow night at 6 o'clock, the collision interwebs. Who done it? So we've been tracking some repairs over the past several months, and we're going to kind of go through some of them and a little bit more lighthearted conversation and a little happy hour.
We've got to be careful because depending on how that goes tomorrow night at 6 o'clock, we might have to change the schedule on Thursday because 7 o'clock, 8 o'clock in the morning on Thursday might be our indictment hearings
it might be,
at county courts. So we got to see what happens with that.
Yeah. So packed schedule tomorrow, and as I said, we're kicking off in the morning with the Celette crew. And until then, everybody have a great